Good morning, guys. Today we're going to be doing a Centripetal Force lab, okay? And we have a hanging mass of unknown value, and we have a glass tube, which is hard to see, and a rubber stopper that this is connected. The string is connected and runs all the way through the glass tube. And what we're going to do is actually swing this rubber stopper in a horizontal circle and observe what we witness with respect to the hanging mass. The faster I swing this, the greater the radius gets, and the hanging mass starts to rise. Okay? If I start off here, just get a little bit going, I have to go a little bit faster. I can slow down that speed, and eventually tension force starts to pull down and the hanging mass comes down. So trying to find a point where I can count and maintain a constant speed and where this hanging mass is basically in vertical equilibrium. So I'm going to add a piece of tape here as a visual indicator to track to make sure I keep it at the same vertical spot. So I've added a flag here using some blue masking tape, and I've also made a black mark with a marker on the line on the string. So what my goal here is to do is I'm going to spin this around, and I'm going to really try to keep the end of the tube even with the black mark on the string, and I'm using the flag as another visual indicator, okay, of keeping that space appropriate there. So ultimately I'm trying to keep it from moving up and down, which is telling me that this hanging mass will be in equilibrium due to the tension in the string and the force of gravity pulling down on it. Now, you do not want the flag resting and pushing up against the tube, because there was a friction force there that is being factored, that would not be factored into your calcs, your analysis. So you don't want the flag pushing up against the tube. You want to leave it a little bit lower, and I suggest making a mark on the string with a marker. Now, I'm going to measure this radius. So when the end of the tube is lined up with that, I notice that this becomes my radius as this thing is spinning around. So I can use my meter stick to go ahead and measure what that radius is, and I'll now have the radius. Okay, so here we go. I'm going to actually get this going here, and to determine our period, we're going to time how long it takes to do 10 full revolutions. So I'm just kind of going to get this started. And you can see I need to go a little bit harder, faster, right about. That's too hard. Let's slow it down. And reach equilibrium. Let's say. Right now. So we'll have timed how much time there was for 10 revolutions there. And that would be for the first hanging mass. And I'll give you that data here in a second. I'm going to add a second mass to my hanging mass set here. Again, I don't know how much this is at this point. And just for time's sake here, rather than readjusting this and changing the radius, we're going to keep everything the same, except now we have a larger mass hanging. Okay, so it's going to change. So I would expect if we're keeping the radius the same, my velocity is going to have to increase to be able to counteract the force of gravity here and increase my tension force. So we'll see what the data shows us. And we can go ahead and record now. And there you have it. So I will share that data with you so you can complete this lab virtually.